little bit what vehicle tracking is. Not sure how much you know about the history of it. It's a product that we have as Autodesk acquired. I think it was last year in summertime. It was an acquisition of technology from Savoy Computing in the UK. So you might know that product. Or have seen that product in the past. So basically it's the Autodesk flavor or the Autodesk version of that product that we had in the past. And actually it contains a couple of things. It's not only doing a swept path analysis, and swept path analysis really means looking how a vehicle behaves into your design. There's an extensive library of vehicles for specific countries and for specific purposes, and you can do the swept path analysis of that. That's obviously one part of the solution, but then there's two other modules included, which is a parking layout module, which allows you to fairly easily do parking lot design and reporting the number of bays you have, and actually automating the drawing process of that. And the third solution of vehicle tracker, or the third part of vehicle tracking, is the roundabout design tool, which allows you to, based on design standards, everything we do in vehicle tracking is based on design standards, but based on design standards you can do preliminary design of a roundabout, and this is can be done in 2D and in full 3D as well. So there's a strong integration with Civil 3D that allows you to interact with Civil 3D alignments, profiles, terrain models, and so on. But it's not required. I think that's an important thing as well. It can be done, or it works in plain AutoCAD as well. So if you look at all the products we are integrating with, it's all AutoCAD based products like Civil 3D, but also AutoCAD Architectures, plain AutoCAD, Map 3D, and so on. So you don't see Revit in the list, which is correct. We don't integrate directly within Revit, but if you have a building design suite, you have an AutoCAD available in that building design suite as well, and then you can bring your Revit models into AutoCAD base and then do the swept path analysis and so on. Okay. So as I mentioned, accurately predict movements of steered vehicles. As you see, this is an example of an exceptional transport vehicle, but that's only one of the libraries, or one of the vehicles that we have available in libraries. And when we mean steered vehicles, we actually mean everything that has wheels. That can be a truck like this, it can be a normal car, but we also have had machinery running into storage locations or hospital beds, wheelchairs. These all have wheels, and we can all or we can use vehicle tracking to do analysis of that. And a nice example in the building space was analyzing the movement of hospital beds in the hallways of a new hospital design. So that's how far we can go. So a little bit beyond roadway design, but well, it's one of the possibilities as well. And we can perform fairly detailed checks with the swept path analysis. For instance, what you see here is a diagram showing how much steering is required to do parts of the swept path. So you can maybe it's technically possible to run along a certain road or a certain parking lot, but sometimes you need very heavy steering, so it might be better to optimize or to change the design a little bit so you can keep steering to a minimal. So it's more about optimizing the design, even if it's theoretically possible, and we give you some feedback, some reports to help understanding how that all goes in vehicle tracking as well. We can animate the swept paths we have done. So what you see here is a little video. Not sure how much the lag on the screen is. Yeah. So this is a little animation. I will show it live as well, where you can do 2D or 3D animation of the swept path within your CAN environment as well, which gives you a nice idea of how vehicles are moving around. Okay. Then then we have, as I mentioned, two different tools, which is the parking layouts and the roundabout tools. I will give a short overview of its capabilities as well later on in the live presentation. I think that's worthwhile most instead of listening to a PowerPoint. One thing to mention with the roundabout design, that it is all based on design standards. So we have a lot of design standards in there. It is fairly easy to build your own design standards if you have them, and then you can again visualize it and see analysis results as well, which I will talk a little bit more about later on as well. Okay, so integration with Civil 3D, so everything I've been mentioning until now was actually examples on AutoCAD. So we can integrate with Civil 3D. What you see happening is that that truck is driving over a Civil 3D terrain model, which allows you, for instance, to do ground clearance checks. It interacts with Civil 3D profiles, it interacts with Civil 3D alignments. It will create a complete Civil 3D corridor or 3D model for the roundabout and so on. So there is definitely a very, very good integration with Civil 3D as well. As I mentioned, analysis design or analysis results for the roundabouts. Again, you have design rules attached or as the basis for your roundabout. What the software will do, it will calculate at what speed you can take, for instance, the roundabout going from the bottom right leg to the upper right leg. If that speed is beyond the acceptable speed, then you will get a red color indicating that actually this is not so much a safe situation. Roundabouts are primarily intended to slow down traffic and to optimize the amount of cars that can pass that roundabout in a short time. But if that speed is too high, well, we will give you feedback on that, or the tool will give you feedback on that. And you can very dynamically modify parameters of that roundabout. And again, spend your time optimizing the design instead of spending your time doing drafting and replacing line work, pedestrian crossing lines and that kind of stuff. That is all done for you in an automatic way. Okay, so a couple of other additional analysis tools we have. You can visualize, if you want, sight lines for vehicles. That means sight lines. What is the driver of the vehicle seeing? Okay, it's not doing real clash detection at the moment. It's not saying, well, you have a problem in this situation. No, it shows you the sight lines, and then it's up to you to decide, well, that big building is blocking most of the sight lines, so maybe it's not that safe situation. And it works in both forward driving or reverse driving, and because that's also possible. We can steer forward, but we can steer backwards as well. Multi-axle vehicles, or combined vehicles we have in the libraries as well. Complex stuff is all available, and I'll go through that library to show you a couple of examples later on as well. So this is time for me to go to some product presentation, and I'm running in Civil 3D at the moment because I want to show the Civil 3D integration at a later point as well, but I'll actually start with some basic AutoCAD examples. What you see here is a 2D layout of some roadway, which can come from anywhere basically. And actually, if I install vehicle tracking, I'll have an additional ribbon of the functionality in my environment. And then you see actually you have the swept path part, the parking part, and the junctions or the intersections part. And the review part is there where you can do some customization on how you see things and animations as well. Okay, so if you look at the library, so the first time I start the product, you will see that I need to load the library, and I'll go through it fairly quickly, but I'll try to give you an overview of what we have available. For instance, we have aircrafts. So if you have a customer or a project that involves aircrafts, we have a big library of all commercial airplanes. So we can do that analysis as well. We can show contours of the jet blast when it's running idle, when it's taking off. We can show contours of the noise of this aircraft. We can, if we have service vehicles connecting to that aircraft, for instance, to push it back from the stand, or vehicles for loading the baggage into the vehicle, or bringing the trolleys with food and drinks in the vehicles, we all have that linked to these plane models, and we can analyze them as well. So if you are in airport business and you want to visualize, do swept path analysis, and do analysis of a lot of additional things with that airplane, we have an extensive library available. We have a couple of military vehicle aircrafts as well. It's a little bit more difficult to get all the details of these vehicles, as they quite often are top secret. As I mentioned, de-icing machines, baggage trains, we have all these type of vehicles in the library as well. Okay, so it's not just cars, as I mentioned. And then we see an overview of all the design vehicles specific for defined for specific countries. If I look, for instance, to Norway in this list, so we have some handbooks with buses, standard vehicles. They're even translated in Norwegian, so I can't understand any of it. So that's why I'll just go to my Dutch ones for the moment. So I have buses, goods vehicles with trailers, passenger cars, and so on. And they're all based on national standards, right? If you see that at some point for the project you have to run, you miss a specific library, please talk to us. We can do two things. We can make that library ourselves, or we can explain how you have to build a new vehicle within vehicle tracking. And honestly, it is very simple. It's just a wizard. If you have a data sheet of the specifications of the vehicle, it is just reading the figures, filling them into a wizard, and then the design vehicle is being created. So no stress or no worries if you don't see your design vehicles in here. We can easily do that as well. There are a couple of specialist vehicles as well, which one you saw in the PowerPoint presentation as well. Abnormal load vehicles. A low boy is quite a famous one we see, but if you have specific vehicles, for instance, for the wings of a windmill, we have them defined as well here. So, and as soon as I select a vehicle from the library, you see the plan view, or the plan view of the configuration, and some details written in that view as well. We can also go to a profile view, and this is the information, or the all the parameters we have used to define the vehicles. So that explains a good amount of things to you, what the vehicle is all about. Okay, so and when we want to start doing a swept path analysis, we have a couple of ways to do it, but what I'll normally do is go to my design vehicle and say that I want a goods vehicle like this, or let me truck with trailer. I like the trucks with trailers. I double click on it, and then if it's the first time you use the solution, you'll be able to set some parameters, because if it's a plain AutoCAD drawing, then there are no real coordinate systems or no real units attached to it, so you can define, is this a drawing in meters or is it in feet. So basically this is an example in feet, and in this case it's reading my Civil 3D properties. If I have a real Civil 3D drawing, I can define my surfaces. So my vehicle is driving on top of that surface, and then I have a couple of options I can set on layers. I want to have my swept path on a specific layer. Okay, and once I do it, you see the vehicle is attached to my my mouse. I click one time to position it, and then I can rotate it to give it a starting angle. Okay. After I've done that, you see a dialog box popping up, which allows you, if you made a mistake in the positioning of the vehicle, you can just use the commands to modify it. Once I click proceed, you see that the vehicle is again linked to my or to my mouse, and then I can start driving it and just clicking points. And as you see, there are a couple of information you have in that view, and I can just go there, and that that magenta angle you see, that gives you an idea of is the final direction where you are going actually. Okay, so let's see, I have to go there, and then I need to be able to turn in this direction. So I can fairly quickly see, okay, that's not far enough, click 1 point more, and see how nicely I can drive into that location. Okay, and that's the way you do. And basically the lines you see are configurable. At this point it's showing the body envelope for the vehicle, but also the wheels, the position of the wheels as well. So this will be a little bit more difficult, and then you see I'm not a truck driver. Voila. But then you see how again that vehicle behaves. Just escape to quit, and that's the full path you have now for that specific vehicle. And if you see, there are a lot of grips available, and I can take any of these grips to modify my path. So you don't have to delete the path, and you don't have to redo it. You can just use your the grips and change the position of the grips. When I'm doing a too aggressive change, obviously my path will be interrupted because I will be oversteered and that kind of stuff. But the slight differences can be made easily within that environment. As I mentioned, you can animate. So if I play my vehicle, so you will see it's moving. Not sure if it's fully clear on. I'll move it a little bit faster, so you see the vehicle turning around and do that environment. Okay, I can do that as well, sorry, in basic in 3D view. So if I zoom in here and I start playing it, so you see it now driving in 3D. Okay, and then you will see or animated. You can do a recording of that, so you have a little AVI of the swept path, and so on. Okay, so if you have the viewpoint position, if you switch around the viewpoint position, you can define yourself how you actually want to see it. Okay, so there's a lot of things you can do with regards, so let's start again, with regards of setting up the viewpoints for my vehicle. Okay, so it gives you a full 3D animation of that vehicle. Okay, so that's one of the possibilities, one of the options you have with regards to swept path analysis. Okay, makes sense, I hope. Let's see what I can do. Maybe I'll go to something more civilly now, civil 3D wise. I'll go this. Okay, whoop, 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 whoop. I want to have this one. Yes.
We have a question here.
Yes.
Is it possible to see an arc path preview like in Autoturn?
It must be. I'll have to check that and come back with the real answer to that. So if you can write down the question, Sven, and I'll have a look at it and I'll come back with the answer to it.
Yeah, I will send it to you.
Yeah, okay. So although I don't have the answer, come on, for you at the moment, I've seen or I've heard that there is not too many things, or there are no things Autoturn can do that we cannot do. It just looks a little bit different, maybe. Good. Same thing if I do swept path analysis, and I'll just take, for instance, this low boy configuration. Then again, it's asking me for my information, so it's meters in this case. And I'm saying now that my terrain model is an existing ground surface. I have no final surface, no design surface. Okay, and then I can drive that low boy configuration here as well. And maybe I'll drive somewhere where I might expect. Okay. So as you see, I stopped my configuration, or I stopped my how say it, my swept path, and when I select my swept path, I have a plus here, and I can just continue where I left off. Okay, so that's again something fairly easy to use. So once I have my swept path, I can do a clearance analysis. Okay. Yep. And basically what it is doing, voila, it's showing me if I have a problem or if I don't have a problem. Let me see. Oop. Okay, apparently I don't have problems in this surface. So if I would have a problem, it should color me my path with different colors. So apparently this is not happening at this time. Okay, one thing I forgot to mention actually is that when I'm driving a vehicle, I have a couple of other options as well. So come back to my library, go to my truck again, and let's say that I'm driving it here in that direction. Proceed. I'm driving here, here, here. And actually I want to take that corner, but I don't want to do it manually, so I can also pick a line that it has to come through, and it will automatically calculate for you what's the easiest way. So you at this point parallel to the selected line, or and then you can click the point, and then it will calculate what the shortest or the easiest way of taking this curve is, which is fairly interesting, certainly when you go into parking bays and in docking stations for vehicles as well. So that's one of the things I wanted to mention as well. So talking about the turning diagrams we've mentioned. So with my certain path I can have some diagrams showing the turning curves or the turning rate of my vehicle, and I apparently have some graphical issues while broadcasting because the textual values are not shown. It should show here the percentage of the steering rate of the vehicle, but since I'm broadcasting over the internet, it seems to ruin my graphics display a little bit at the moment. So this is for the swept path analysis, and again you have a lot of options to modify the swept path and visualize it in a different way if you want to. Okay. Vertical clearance, I haven't mentioned that, but vertical clearance is basically, let's see if I have a little example of that. Editing, Amazing. Vertical profile clearance. Okay. So this is just an AutoCAD polyline. If I go to vertical clearance, my default vehicle is a bus. Again, it asks me for my parameters, and when I click on that line, it will show the vehicle and the profile and stop where you have the problem, and you visually will see where the body of the vehicle will connect to that or go through or crash into the ground. So this is something which is impossible to take for the bus. So if I look at for instance, a civil 3D surface profile, I can do the exact same thing. Vertical clearance, but now I'm going to select my native civil 3D profile, and then you see in this case it is fairly easy for the bus to take. You can add the detail of the vehicle as well here in a cross-section view. You can add the chassis outline symbols. Okay, so you can just place these profiles during or along the profile as well. So, and as soon as it goes all the way to the end, you're clear. It will just stop its vertical profile at the point where you have the problem, as you have seen in the little example below. So here it is not well, so there the vertical profile analysis stops. Once you optimize your design, you have to rerun that vertical clearance analysis. Okay, so that's that couple of options you have within the swept path analysis. You can also do manual drive if you want to, like in a gaming environment where it looks like you're steering the wheel using your keyboard keys. But normally the functions I've shown you is what most people I know are actually using at this point. Talking a little bit more about the roundabout design. Okay, so what I have here is a civil 3D drawing, okay, which has again my terrain model, which has alignments, and the only thing I have at this moment is 2D alignments. I don't have vertical design profiles. It's only 2D alignments, and I have a crossing location where my two alignments will cross. So I want to build a roundabout. Again, we have a couple of roundabout design standards, much less than the vehicle libraries, but again it's fairly simple to build a new design standard. So if I take a standard normal roundabout with a single lane, okay, double click on it, I'll start my roundabout tool. I have some presets I can do with naming the objects, giving colors as well. In this case I'm using a dark background, so the line colors of my roundabout will be light, which are fairly easy to see. And then I also have my my civil surfaces available in this case. Okay. What happens is that you have the roundel of the roundabout, which you can dynamically place. It doesn't have to be in the intersection point. You can as well just put it over here. Okay, so that's now updating already a couple of things. Next question being asked is, what are the connecting alignments? And that can be an alignment in my case because I have a civil drawing, but this can be simple 2D polylines as well if you only have an AutoCAD drawing. And you see dynamically it is building my 3D corridor model and my geometry for the arms as well. If I take this one now, okay, this one now, 1, 3, and I have number 4 as well. Okay. And then when I click enter, it's actually updating a couple of things and building my complete 3D corridor model, which can take a little bit of time in this drawing as well. Okay, but actually what happened is you have built, based on the design standard that you have chosen, a roundabout with the rondel and all the connecting legs, and it will automatically use these design standards to define the connecting radii and so on, and a full 3D corridor is being built at this time in my model. There are a couple of more things you see. So again, you see a lot of grips. If I move my roundabout around, you will see that all my connecting legs, all my connecting elements are being updated as well. If I just replace it, my corridor will be rebuilt again as well. What else do you see? The red lines, for instance, these are the driving lines. Okay, these are the driving lines of the vehicles over that roundabout, and the one that's orange, this is your fastest driving lane. And the speed you can use to, and I'm just gonna update options, colors, line close, okay. To see, no, it's as I said, something is wrong with my graphics display at the moment, but you should see the values here of the speeds that you can drive, what the radii and the connections are. So this is what you see is a real Civil 3D alignment, which can use Civil 3D functionality modifier. It uses Civil 3D styles, it uses Civil 3D labeling and all that kind of stuff as well. So once I have that roundabout, I can start playing around a little bit with it. For instance, there are a lot of more geometry that we can add to it, which can be, for instance, pedestrian zones. So for instance, I have a couple of options here saying this is my roundabout, my junction. This is ribble stripes, sorry for that. This is ribble stripes, so which can be placed for slowing down. Oh, that's why this is so slow. Okay. I'll go to wireframe. So this is adding ribble stripe, and that's why I didn't see it, sorry. So that's the speeds I was talking about, and since I've taken a British standard, it's in miles an hour. If you take another standard, it's in kilometers an hour. So this is ribble stripes slowing down the traffic. If you want to add an island in the junction, so basically in this leg or let me take another one to see if it's a bit better. Yep, here you add an island, so it will automatically create the geometry for you. So this yellow line now is the island between the two lanes. Okay, there it is. And then when you have the island, you can as well add some pedestrian striping. As you see, it's fully dynamic. So again, you can spend your time optimizing the design instead of doing your drafting work. And once you have done all that, you say, well, maybe I need to change some of the properties. Then you can go into not this one, into this one. Edit roundabout. Where are you? roundabout, vehicle tracking, voila, that's the one I needed. And so basically what you see is the dialog box giving you all the parameters of the roundabout, the central island, and basically what these design standards do for you is that you can define a minimum and a maximum diameter, and it will have a standard value as well. And you can change any of these values as you want for any of the properties in that roundabout. That's for the roundel itself. You have parameter for each and every single entry. If I click on a value, you see in the view on the left side what it actually is, which value we are meaning, which radius are we talking about, what again, what are the standards you have available. Same for the pedestrian crossings. If you have a pedestrian crossing, if you have rumble stripes, you can easily see all the parameters and the information for it. Okay, so let me see. This is the second one, I guess. My pedestrian. Here I have a pedestrian area or a pedestrian crossing. I can also change the parameter, for instance, for how it crosses my island. So my island is split into two now. If I say, well, none, apply, my island is closed again. So it's just by setting parameters that you can do a lot of automation of your drawing work of that roundabout. And again, you have 3D corridors, you are building alignments and so on that you want. Signage, there are signs placed automatically, as you see. So we have signs defined within vehicle tracking itself. There is a link with DesignLine Pro, which is an additional tool which gives you more detail in the way you can define or place road signs. And again, if just look here, you have a full 3D model, 3D corridor model of your roundabout. And then you can do a lot of civil things with it, really, do cross sections, do volume calculations, and so on. So that all because it's a civil 3D object. And again, it's very flexible. If you have your roundabout and you're moving it around, and that's what I wanted to show you at some point. You see now the color is going red because you can cross the vehicle on the table on the right top of my screen, and on the left side you see two red parts in the table, which means, well, if you build your roundabout like this, you will be able to cross it with a much too high speed. And it gives you a lot of feedback on that side as well. For the ones, I'm not sure if there are people from the UK as well, you can link it with Arcady, which is a mandatory tool to use when you design roundabouts over there, so that it has a link with that as well. Okay, so I heard that I have 45 minutes, so I only have a couple of minutes left to go to my parking layout tools.
No stress, Peter. If we take 5 or 7 minutes extra, that's no problem.
Okay, thank you. So last little thing I wanted to show you is the parking area tools. It's completely 2D tool. It's no 3D involved here, but it really helps you. Automating again some of the drawing for a parking layout. So I'll use the British standards again. Again, the same options come up, and then I can create parking bays having two-way flow direction, one-way flow direction. So basically, let me say I only have start to end. Yep. One start to end. Can set a couple of options here, and it's just a matter, and I'll just show it here to show, before I go into the detail, to show you and explain you what the different types of the design are really. Okay, so if you have drawn a parking bay, you see, depending on how you have specified the criteria, it's adding a lot of base itself, but it's also adding the islands, the connecting islands, and these blue lines you see, they define the area that is needed for the vehicles to easily get in and get out of the base. And one of the things I like most about this whole tool is that if you have a parking bay like this, with one click on a button you see you have 228 parking bays in that design, where they're all standard. Okay. One of the things you probably might want to consider at a point is if you edit a bay, for instance, and I can take one or I can take a whole lot, that we can see that it is not a standard bay, but it's a disabled bay. Okay. Then what you will see happening here is that you have the sign of the disabled, but the parking space gets bigger as well. Okay. So if I'll take this one and do that, okay, copy to, and I can then copy it to multiple bays if I want. Okay, so now I have a series of disabled bays, a series of standard bays, and again with one click I now see, well, you have 200 normal, now you have 5 disabled bays of the single type, or one of the single type and 5 of the multiple type. So, and then you see the percentages as well, because for certain countries, and I don't know how it is in Sweden, but for certain countries you need to have a certain percentage of the bays need to be disabled bays. It can be 10, it can be 20, whatever it is, but then you can easily see if you meet the requirements, yes or no. What else can you do? Let's say that you want to have an access road. You just select a line or draw a line, or you select an existing line. Define the properties of the access road. Is it a two-way or a one-way exit road, meaning only exit, only entry, or in and out? You can say that it is based on the design standards. You can add whatever you want, and it will automatically split your bay into 2 different zones, giving you the distance between the islands that are required within the design standard. Again, a lot of grips here. What can I do? I can change the angle, for instance, of one of the bays. I can, that's one of the bays. I can also put the whole line in one go. Okay, so the 2 bays, I can make them wider, I can make them shorter, I can make them circular. If you have a circular area, I can I can extend them by just clicking elements, and so on. So very flexible again in the way we do manage, and we draw this parking bays in an automated way. So no need for you to do all the manual copy paste and so on the parking bay. The software assists you in that, and again, every time you do something, you're up to date with the number of parking bays you have. Not sure if I haven't mentioned it, but when I start a new series of parking bays, yep, take my standard again, okay, you have different types. This is 2 directions or 2 parking rows connected to each other, but you can have kind of different situations that you can define. So this one is, for instance, another way I can do. I'll take this one, but only the left side of it, to have one single row and not a double row, and then I can just link it into my existing AutoCAD drawings. Right? It's fairly simple to do. And again, you see all the analysis results you have for the space required by the vehicles going in there as well. So I can do this, but I then can change it to have the curves and all that kind of stuff easily. So fairly simple tools. It's just drawing automation really, but it gives you some feedback as well on the available spaces you have in that area. And then it can be combined with the sweat path analysis, and you can automatically park the vehicle in the bay and so on. So there's a couple of options we can do with that as well. So this is fairly quickly, I think, but still hopefully a good overview of what vehicle tracking can do. There's probably much more detail to it, and if you have questions around these details, please let us know. I think we still have time for a couple of questions, right, Sven?
Yes, there is one according to the roundabout, and it's can you make an S-curve before you go into the circulation?
No.
In Sweden we have a stat. You can't that. Okay.
Not at the moment, and that's why we say it's preliminary roundabout tools. If you want to do the S-curve, you might, what I would do then, you might start with the roundabout tool and then start modify the geometry and update it manually. That's how I would do it. But the complete S-curve before the roundabout is not possible in one single click, basically.
Yeah, that's good. And then there was another one, also according to the circulation. It's how do you get the heights in the roundabout? You had no profile or model.
So basically, there are a couple of options. That's a good question. I forgot to mention that. There are a couple of options. If you have design profiles, it will use the design profiles and connect to the design profiles. But what we quite often see is that you have kind of a reference surface that you use as the basis, and that if you define that as your proposed surface, here you have seen in my presentation that I had existing ground surface and final ground surface. If you say that a reference plane as the proposed surface or the final ground surface, it will project to it and connect all the profiles directly to that reference surface really. So that's the method that the two options that we can use. Okay, make sense?
Yeah.
Or
yeah, I think so. I will talk to the guy who asked the question afterwards, but I think that's a good. It's a good answer, and it was, as you say, a good question also.
Yeah.
That's what I had. Maybe there will come some later on, and we can have contact through email or something if something else comes up.
Yeah, please, if something comes up and you just don't think about it now, send the question to Sven, and Sven will probably find me as well, so that's not a problem at all.
Yeah. Okay. Well done, Peter. Thank you very much.
You're very welcome. So please let me know if there's anything you need from my side.
Absolutely. Okay. Thanks, everybody. Hey, one more question. Thanks, Peter.
Okay.
That's nice with it. That's nice with the H-stead values in the circulation. So I think people are satisfied with everything, and it was a demonstration in 50 minutes. I think it's very good. So thank you everybody for attending. Thank you, Peter, for the demonstration. Goodbye.
You're very
Have a
welcome.
nice weekend.
The same to you all. Have a nice weekend.
Bye.
Bye now.